So here you have it operating off the signal generator output. I'm sending a square wave in there, and you have a full stroke from back and forth of this ½ dimension in each direction here. And like I say, that is 6 Hertz. And if I try to hold on to that, as you see, my hand is shaking. It has quite a bit. I'm holding here with a lot of strength, as nearly as hard as I can. And as you see, it's still moving my hand. And there you go. It's going again. And here is the scope shot. And if we look at the voltage, we have about 9 volts RMS there. And we have a consumption of about 200 milliwatts as it's working right there. And what I'll do right now is hook it up to the speaker, and we're going to look at the action that the speaker has. So that is the action of the speaker, and with just one little finger I can pretty well stop that action. There is no movement of my arm or anything like that. There is no need to hold it in any way, and that is the difference there. So mostly a lot of huge amount of mechanical power compared to the speaker. And if we look at our math, because of the smaller DC resistance, the voltage is getting squashed. So we have about 2 volts RMS, and we have 250 milliwatts being used, and that's what the scope shot looks like. Now what I'll do is I will go up one step, and we will look at a different frequency here. I'll have to reset my time division here. So if we look at, this is a 100 Hertz right now that's going to the loudspeaker, and it is utilizing 330 milliwatts to do that. And now we're seeing it, and I can put my finger on that and stop the action pretty much. And now we'll go to the mostly magnet motor. Now there is no sound because the movement is very small, and there is no cone to produce a sound. But now if I put my finger on there, I can feel the same amount. Even if I hold it hard, I feel the same amount of vibration of strength that I was feeling by holding the speaker here. Okay, and you're not going to see the back and forth movement because it's just minimal at this frequency. But if we look at the waveform, it's very, very different. And if you're familiar with power calculation, you'll see that the power is being returned. So the mostly magnet motors working a lot on reactive power. So all of these peaks that are going below the 0 line here in the red, the math calculation is showing you that this is reactive power, meaning power is being returned here at this point. And this is really the consumption right here above the 0 line. And if we look at our power that we're utilizing, we're only utilizing basically 100 milliwatts. So much less than what the speaker was using. But we're not producing a sound because we don't have a voice coil. But if it was hooked up to a voice coil, you should be hearing as much sound than this one was. Now it's not ideally set for high frequencies with this particular coil that it has been wound, because I should have a coil that's more at 8 ohms. But it's just the comparison, and this is what I had for the demo. and I hope you understand that with a smaller resistance coil we would get a lot more action mechanically as well. You wouldn't be able to hold this. There'd be even more movement, and would tickle your hand a lot more than it is right now. So that is the benefit here of the mostly magnet motor, and hope you enjoyed this demo. Thank you.